Normal distribution. Normal distribution is probably the most important distribution we're going to learn about in the class. Most things in life follow normal distribution, which generally means that if you look at, for example, take height, which generally means that most people kind of fall in the middle. They fall like right here in this middle here, but then very few people are very tall, very few are very short. Like most people fall kind of with this range here, this mean range. That's what normal distribution is. Most things in life fall that. Same thing with weight, right? Most people are kind of average. Few people super high in extreme, super fail on the other side. Arm length. You look at crop fields, they say here, score tests, yeah, like SAT tests, right? The average score for most people on the new SAT is about 1,000, right? You get a few people that score perfect score over here, get close to it, and you have two people on the bottom probably shouldn't take the test and score really low. But that's what normal distribution is. It's the study of like averages and how close we are to the mean and different values. And it's one of the most important distributions that there is in statistics. So we're going to figure out how to do this. Now, for normal distribution, the most important thing is probably, so this is how it's written. It's like before we had the binomial distribution where x is a binomial. Same idea. This is saying we see this. That means x is a normal. So for all normal properties, you want to think of this picture here. Hopefully a better picture than that one. Now, notice this stuff, right? That fancy symbol right there. Mu stands for the average. So if you see this, that's the mean or average. Now, we've seen this symbol before. That's sigma. That stands for standard deviation. But notice the way it's written. It's sigma squared. Right? And that's as they say right here, sigma squared is a variance. That's just a fancy way of writing it. Really, right? It's like if I said, oh, here is 5 squared. You'd be like, oh, variance is 5 squared or 25. Standard deviation is 5. That's what's going to go on. If you see it like this, if you see this notation, take the thing on the bottom that doesn't have the square as standard deviation. So even though technically that's all variance, they're really just trying to tell you what the standard deviation is. They're like, hey, standard deviation is that thing that's not squared. So it's actually supposed to help you out. So that's what a normal distribution is. And when we do normal distribution, all we need is two things. We need those. We need the mean and the standard deviation. That's it. If you have those, you can figure out a lot of things with standard deviation. And now this is the normal distribution curve. Right in the middle is supposed to be your mean. That's why it has a little sigma. That's mu. I meant symbol. Mu. And then every standard deviation, like this is one standard deviation out here. That's why you add that plus standard deviation. You get more data that falls in between this. Now here's the important thing. For this class, for IB Math, you don't need to have this stuff memorized. It's good to kind of know 34.1, 13.5, 30.6, but we don't need to know that. Like, we don't need to have it memorized. Because these problems are only for the most part, going to be done with our calculator. The ones that have to do without the calculator, you could do without having the stuff memorized. So this is all good information, but really, you don't have to memorize any of that. So what I care more about is, you know how to draw it. It's like over here. The chest measurements of 18-year-old male footballers are normally distributed with the mean. And there we go. Normal has to tell you. They're going to be like, hey, we're normal. Hey, it's a normal distribution. That's how you know it's normal. So like, we're binomial, we have to kind of look at it. Is it exactly? Is it at least at most? Normal has to tell you. They sure have to go, like, oh, this is a normal distribution. Oh, okay. So I know what I'm doing. Right? The mean is 95. So you have this is 95. And the standard deviation 8. Or again, they should generally always give you that. If they're trying to be fancy, they might give the variance. You just take the square root of it. But they're going to give you that information. So in our little picture here, and we're going to draw lots of pictures. This is 95. Standard deviation is 8. So I could go 8 in each direction. But again, it's from what we're going to do, that's actually too much work. Why can't we understand this concept? Okay, 5% of football chest measurements between 87 and 103. Well, 87 is over here somewhere. It's like 8 away. 103 is 8 away. It's over here somewhere. So you want to kind of symmetric. And you're looking for the people in between that stuff. We'll figure out how to solve this with our calculator in a little bit. Now, if you have the stuff memorized, you can add it. It's 1 standard deviation each direction. It's like 34 plus 34, around 68. But again, in this class, you're not going to need that. Over here, between 103 and 109. So again, I just care right now that you understand more of the concept of how to solve it. So this is standard deviation, right? This is a normal curve. Now, a couple things I forgot to mention. All this is 1. Like, it's all percentages. So just like our max probability is 1, same thing with this curve. If you find all the area underneath here, it's going to be 1. It goes from like 0 probability to 1 probability. Now, remember the middle is the mean, so in our case 95. Now this one goes 103 to 111. So 103 is like up here somewhere. 111 is 8 off. So that'll be 103 to 111. Again, if you have the percents memorized, that's like 13.5, but it's not a big deal. I just care right now that we understand how to draw this, because that's the most important thing when we get into the next little part of this. Now when I get to B, find the probability that the chest measurement rounding shows the football is between 87 and 117. We kind of already did that, right? Here's 95. 87 will be over here somewhere. 103 is over here, so 111 is over here. So it should be a little off scale, right? It should lean way more to the right than it is to the left, because I have more on this side. And IB will mark you off for that. If you make it look like that and it's not supposed to look like symmetric, they'll mark you off a little bit. Now let's look at this one. We're going to talk about this actually more in the next video, but find the K value such that approximately 60% of the chests are below K. So they're giving the opposite. So it's a little preview. They're giving you the percentage. So it's a little preview here. They're telling you that some values are below K. So the trick is when it says below, you start on the left-hand side. So you can go like over here, and that's going to be like 16%, which makes this value of the sign here your K. Okay, we'll do more of that later, but that's still a preview. When they give you the percentage, then it's all about starting from the left side or the right side. If they say below, start on the left side. Say above, start on the right side. But again, we'll talk about that in a later video. Let's do another drawing before we actually start solving this. The mean average rainfall of Caledonia for August is 48 millimeters with a standard deviation of 6 millimeters. Over a 20-year period, how many times would you expect less than 42 millimeters of rainfall during August in Caledonia? So again, normally you would see normal. This one they don't say, but like on the test, they have generally tell you it's normal. They're going to tell you it's a normal distribution, so you know how to use it. So in this case, right, here's my average rainfall. So it's my mu. It's my standard deviation. So again, right now I'm not care about solving it. I'm curious about graphing it, because that's a big part of how to do these. So that's 48. You want less than 42. So there's 48, 42 over here somewhere. And you want less than, you want all this. So it's going to go from whatever less than 42 is all the way to 42. Again, if you have the percents memorized, you can figure this out, because this halfway is 50. That's half of a thing. So if you want the percentage, if you have them memorized, it's 50% minus this inside one, which I think is 0.34. And you actually get the value. It's about 0.16. 60% chance of falling rain. But again, we'll talk about how to do this right now with a calculator. So this is how we're going to use our calculator. So keep in mind we're doing normal now, as you can tell by this thing. Now here's the thing about normal. If you notice, if you look at the picture we're drawing, we're going to find the area of all this, or if you look over here, in between these two, that's a cumulative area. So for normal, all we ever use is normal CDF. In this class, you will never use PDF. It's only ever CDF. So if you do normal, it's normal CDF. In this class, you never use PDF in this class. It's only normal CDF, because we're gonna find the areas and these occurs between 2 points. So let's look at this first one. Now again, with normal, before I go that, you only need really 2 things. Like I've been saying, you need the average and you need the standard deviation. If you have those 2 things, you generally can solve a normal problem. I can see the x value, but same concept. So look at this first one here. X is approximately normal. Now, again, the way to do this is that your average is 10, and that's a fancy way of writing variance, but really they're trying to give you the standard deviation really cheap, easily, 2.3. So before I even start using our calculator and bringing it up, let's just draw this. A, that's an A. Halfway is 10, because that's the mean. Now H should be 2 away, so don't go too far. Like That's like 8. And then 11's 1 away, so it's a little closer. We're trying to find in between these two. So let's look at our calc. Oh, before I do that, right? Also, that's our mean is this. Standard deviation is 2.3. Remember, that's a fancy way of saying variance, but we just want the standard deviation, so ignore the square basically. So how we're going to do this? Well, let's bring out our fancy calculator. So there's my calculator, right? So we're going to go back to distribution because now we're doing normal distribution. So second distribution. Now, luckily for us, it's one of the first things you see. Now again, we're never going to use PDF, never in this class. We're going to use normal CDF and then at times invert normal. That's it. So in this case, I'm going to do normal CDF. And you get a screen like this. Right, they have lower, upper, mean, and standard deviation. Let's bring it back. Right, so in this case, the lower bound is just going to be 8, because that's how far I went. Upper bound is just going to be 11. That's as far, you can't read it here, that's as far as I went. The mean, they tell me is 2.3. They did it kind of underhandedly, but they told me. Oh, sorry, the mean is 10. Missed that a little bit. Standard deviation is 2.3. And then you hit paste. Hit enter, and you get your value. The object in between 8 and 11 is just the value I had before it went away. 0.476. Right there, sig figs. And that's the idea of in between the two things. You just get lower bound. That's the idea how you do normal. You use your calculator. You can go to normal CDF. Lower bound is whatever the lowest value is. In this case, it was 8. Upper bound is the highest value. So in this case, it was 11. It's 11. You put your mean. You put your standard deviation. And you're done. Now let's talk about the other ones. They're a little different. See, this one only wants less than 12. So if I let them draw real quick. Here's 10. 12 is over here. And you want less than it. So everything below 12. Now I kind of have a problem here. I don't know what my lower bound is. I know my upper bound 12. Upper bound. Lower bound I have no idea though. As most of you can see, it looks like it's negative infinity. It keeps on going lower and lower and lower. There's one problem. We're doing binomial. We don't get to use numbers like that. So what we're gonna do instead in our calculator, we're doing continuous. I shouldn't say binomial. It's normal. The idea is we can't put negative into our calculator. So what we're gonna do instead is we'll pick a really big number, and what we pick is E99. I'm not sure how to use it right now. And in this case, particularly negative E99. That's just basically saying negative infinity is where you're starting, and you're gonna go all the way up to 12. So that's my lower bound. My upper bound is gonna be 12. My mean is still 10. My standard deviation is still 2.3. So let me show you how to put this all into your calculator. When you click your calculator, you go second distribution. Now we always use CDF, we never use PDF. Hit enter. Now how do I plug in negative E99? Well, very carefully. First, let's use the negative. Second, the E, it's not the exponential. It's not E equals 2.71. It's the special chemistry E right here, the double E. That's the one we want. So that's the one. Keep that in mind. It's like a double E. But notice how I write it like that. I didn't write the E like this. I didn't write it curve. I wrote it capitalized. So let you know it's this one. So second E, 99. We're going all the way to 12. Everything else is the same. Paste. Hit enter. And 0.807. So you get 0.807. Now keep in mind if you have an older calculator, it's not going to look like this, but it's the same process. It's lower bound, upper bound, mean and standard deviation. Or, get a calculator for the current era, not 1984. Next, this one right here. See, the exact same idea, right? Probably x greater than 9. Well, let's switch. So let's first just draw it. That's a horrible drawing. Sorry. There's 10. That's our average, right? Now we're going greater than 9. So here's 9. Now think about, notice how this one's greater than that one's less than. Normal doesn't care. Normal is continuous data. 1 point doesn't matter. So greater than, less than has no effect. Binomial, very big deal. Normal doesn't matter at all. Greater than, less than, or equal to, that part doesn't matter. That's what I meant, by the way, when I was talking about that. Greater than, less than, or equal to, right? The line doesn't mean anything, right? Less than, you do look this way. Greater than, I'm going to do it right now. But the fact that it has no line for equal to doesn't mean anything for continuous normal distribution. So anyway, here you go. X is greater than 9. So let's say this is 9, and I want greater than. So it's all this. The good thing about normal, it's putting in your calculator, right? Lower bound is 9, so starting at 9. Left to right, like we're reading a book. Upper bound is infinity here, but again, we can't write infinity. What we do is we write E99. Arrow. Right? And then we're going to, oh, it's an E. Oh, that looks ugly. And then everything else is the same. Mu is 10, standard deviation is 2.3. Right? Same idea, we're going to plug this in our calculator real quickly. So back to normal CDF. So second distribution, normal CDF. Lower bound is 9 this time. Upper bound is E99. So second E, chemistry 99. Everything else stays the same. Hit enter. And about 6.668. And that's how you do a basic normal CDF problem. Okay, we're gonna talk about a couple more, but I won't go to the trouble of like wasting your time plugging them in. We'll just draw them and then you get the idea. In 1972, the heights of rugged pairs were approximately normally distributed. So again, now you know it's a normal. They have to tell you. The mean of 179, that's your mean, and the standard deviation is 7. That's your standard deviation. Final probability of Rhinestock pair in 1972 was at least 175 feet, 75 centimeters tall. So remember, at least, think about it like I want at least 3 cookies, so it's greater than or equal to 175. Right, so if I was going to draw this, my mean is 179. 175 is over here. And I want greater than or equal to. So I'm going to do all of this. By the way, I don't think I mentioned, but halfway is 0.5, so it would be 0.5 plus that if you haven't memorized. But why? We have a calculator. So we'll do lower bound is 175. It's lower. Upper bound is the max, which in this case is E99. The mean is 179. And the standard deviation is 7. Those are supposed to be the harder ones. These are the easier ones. Between 170 and 190. This here is 179. I don't mean it had a little tail in the end, by the way. 170 and 190. Well, 190 is a little bit bigger than 170 in the sense of like it's 11 apart. This is only 9 apart. But put them in. This is your lower bound. This is your upper bound. Standard deviation. Or, sorry, mean actually. And standard deviation they told you was 7. Put it all in and get your answer. This is honestly about the same thing, so I'm going to skip this one, right? There's your mean standard deviation between lower bound, upper bound. At most, I guess I could talk about this real quick, right? At most 70, x is less than or equal to 70, right? 70 is the max. So that's going to be your upper bound, right? If I draw it, because again, this helps to draw it. The mean is 56-ish. This is 70, and that's the most. So you're going to do everything below it. So lower bound will be negative E99. Upper bound will be this. Plug it in and you're done. At least 60, right? That's x is greater than or equal to 60. So we go, looks something like this. Again, this is 56 something. Here's 60, and you want greater than or equal to. Right? And that's how those two are taken care of. Let's look at this one a little bit. I'm not going to do the whole problem because I didn't copy it down, but I do want you to notice that on this one they give you the mean and they give you the variance. Right? They didn't give you standard deviation. You got to remember, this one's bigger. So the standard deviation is just going to be square root of that. W standard deviation, there's your mean. You can solve any problems you want normally with that. Let's go to one last one. Apple summer grower's crop was normally distributed with a mean of 173. Again, notice how they tell you right off the bat. It's a normal. It's a normal. I'm trying to highlight it, not block it out. So you know you can do normal distribution. Your graph's gonna look like this. Ish. The mean is 173, so there's your mean. So right here, right? It's my average. Hopefully it's supposed to be a straight line. It's getting worse and worse, so I'm gonna fix it. Or make it worse. It's 173. Just gotta live with it. Standard deviation is 34. So right, that's my standard deviation. I got my mean is 173. Apples weighing less than 130 grams were too small to sell. Final proportion of apples from crop were too small to sell. So what does that mean? How many of them are less than 130? Right? So here's 130. You're looking for this. So for that one, you're going to go, right? Negative E99 because it's on the negative side. Comma, the max, the upper bound, which is 130. Comma, the mean, which is 173. And the standard deviation, which we figured out was square root of 11. Did I erase? Oh, sorry, 34. Square root of 11 is the last problem. Plug in your calculator, you're done. That's not the reason I want to do this problem. That's normal. The reason I want to do this problem is look at the second one. Find the probability that a picker's basket of 100 apples. Find the probability that in a picker's basket there are 100 apples. Up to 10 apples were too small to sell. Do you know what it's asking? There's 100 apples. That sure would be kind of a clue. Up to 10 apples were too small. So you have two options. It's either too small or it fits or it's too small. This is a binomial question. Right? Our good old friend, the binomial question. Where you need to find N, P, and R. And in this case, N's 100. Probability of P we actually just found. We found it right here in A. So I didn't figure actually the value out. Let's say it's 0.02. Right? That would be my probability. R is what you want. I want up to 10. So R is less than equal to 10. If I put in my binomial, which is less than equal to is the way I want it, I'm done. Binomial CDF because everything less than 10. Now remember binomial is it tells you the number of trials, so in this case that'll be 100. And then it's the probability 0.02. And then what you want for your x value. In this case, we want up to 10, so 10. Put that into your calculator, get an answer. Right? I just wanted to show you that this is what they're going to do a lot now. You might be doing one question, then they just add in, oh, here's a binomial question. You just got to get on your toes and notice, right? Binomials, when you have two options, yes, no, pass, fail. So this one, is it too small, yes or no? And then normal, they have to tell you. That's the key about normal. They're telling you, hey, we're normal. It's a little overcompensating if you ask me, but that's what it does. Anyway, that's the vid.